Hello everyone, my name is Boyuan Chen, and I'm a PhD student from Columbia University. Today I'm glad to present our paper on visual hide and seek. Hide and seek is a common social game among children. Hide and seek is also a frequent activity among predators and prey in nature. In a lot of cases, it shapes the biological evolutionary process. There have been numerous behavior studies under the context of hide and seek on humans and animals. For example, research suggested that perspective taking is an important cognitive ability that humans rely on when we play this game. Rats also show interesting social behaviors when they play this game. Therefore, hide and seek is a very promising paradigm to study social dynamics and social-related cognitive abilities, such as perspective taking and theory of mind. However, hide and seek has been rarely studied in current AI systems. So in this paper, our goal is to perform behavior studies of hide and seek with the state-of-the-art artificial intelligence agents. We would like to know what machine behaviors will be demonstrated if agents play hide and seek. Furthermore, we're interested in knowing what cognitive abilities the system can emerge while playing this game, which can further inspire us about what is missing from current AI system design. So let me first introduce the task. Here, in the simulation environment, we have a hider agent and a seeker agent. One important design decision we made is to make the environment to be a fully visual environment. Both the hider and seeker sense the world through their first-person camera. We believe that this is a more realistic setting while making the learning process more challenging and interesting. Lastly, both agents move at a similar speed. As our first step towards behavior understanding of the agent in our proposed task, we only learn the policy of the hider agent. The seeker agent takes an expert policy. The seeker will navigate towards the hider if the hider is visible, or the seeker will navigate to the hider's last known position and then explore the environment by fixed waypoints. Let me first show some videos about how our learned hider agent performs in the environment. As we can see here, the hider agent shows clear different behaviors. For example, in the leftmost demo, the hider agent always runs away while facing the seeker agent. In the middle, the hider agent quickly moves away from the seeker, but waits there until the seeker gets closer. On the right side, the hider agent chooses to hide around the corner of the obstacle. Although we just observed that there are clearly interesting behaviors emerged during this task, there is no specific studies that can quantify these behaviors, nor experiments to study why certain behaviors emerge. In this work, we choose to use a state-of-the-art reinforcement learning named APPO algorithm to train our hider agent. Our input is a first-person camera image, and the output is the action of 5 action primitives: left, right, forward, backward, and stay. Now we try to understand why certain behaviors emerge. Without deeper understanding about the causes of various behaviors, it is challenging for us to further control the behaviors. And this is an important aspect for a lot of real-world applications, while safety and interpretability needs to be considered. We hypothesize that one important factor that causes different behaviors is different environment setup. To perform a systematic study, we perturb the environment only by one factor at a time and see how things are affected by them. Here is a list of environmental factors that we change, such as the speed of the opponent, the randomness of the room layout, the randomness of the opponent policy, and the reward function of the learning agent. And here are some interesting findings from our systematic studies. First, when we look at the relationship between the ability of the learned agent to infer its self-visibility versus the hiding performance, here denoted by the number of living steps in the game, we observe that models with the right amount of weakness actually cause useful skills to emerge. In other words, environments that are too hard or too easy do not lead to interesting behaviors. From the learning perspective, if the environment is too hard, the learning agent loses the game too soon to explore the environment, leading to less opportunities to learn. If the environment is too easy, such as the hider agent has a very high speed to run, the learning agent does not need to learn other useful skills but run away. Interestingly, we can observe similar phenomena in nature. Additionally, we try to quantify different behaviors with various matrices. For example, here, if representing different game states as follows, we show that at various game states about the visibility of the agents and obstacles, we see that different environments lead to different distributions of game states. Here, we show that one can quantify the behaviors of the learning agent by plotting the distance between the hider and the seeker over time. As we can see, the distance between the agents decreases and it becomes stable over time when the hider and seeker moves in a similar speed, while their distance bounces around when the hider agent moves a lot faster. Now if we look at the faster hider video, we can see that the hider agent indeed uses a run and a stay and a run again type of strategy. For more implementation details and experimental results, please refer to our paper and website. Thank you for watching.